Today's video is all about spheres, and it covers, of course, as usual, surface area and volume. It should be a pretty quick video. So as we always start with some vocabulary, what is a sphere? It's actually the set of all points in space equidistant from a given center. So if you can recall, equidistant means it's the same distance away. So if you have one point and you want to always go the same distance in every direction, then ultimately you end up making a sphere. Now the one that I'm currently drawing looks more like a circle because of course it's two-dimensional, but if you keep doing that in all the different dimensions, then it ends up being a sphere, and one is shown there. So a couple words that you might have to know: the center, of course, right in the middle. Imagine it hovering in the middle of the hollow circle or ball. There is a radius, which is from the center to any point on the circle or on the sphere, and a diameter, which goes from one end to the other end, but specifically it has to go through the center. Technically, spheres don't have any sides, so we can't calculate a lateral surface area. So there will be no lateral surface area for spheres. So when we talk about surface area, we're referring to total surface area. The formula is pretty simple. All you need to know is the radius. It's 4 pi r squared. And while I'm here, I might as well give you the formula for volume. 4/3, or 4/3, pi r cubed. Notice now it's cubed because we are referring to volume. Again, both of those r's stand for the radius of that sphere. Here is our first example. The Earth's equator is 24,902 miles long. What is the approximate surface area of the Earth? So they give us 24,902 miles, and I wonder what that is. Well, that's actually the circumference, because highlighted in red I have what the equator would look like. And it's not a line that goes straight through like the diameter. It's one that's going around the Earth, which would be considered a circumference. I have shown here now the formula for circumference. It's 2 pi r. So if I can fill in what I know for circumference, I can then solve for r by dividing both sides by 2 pi. And I end up seeing that the radius is approximately 3,963 miles. Now I put approximately because there was actually decimal points after that, but since we're dealing with such big numbers, I went ahead and just rounded to the nearest whole. Now to finish up the problem, I actually have to figure out what the surface area is. I know it's pi. Oh, it's 4 pi. Let me go back. All right, now I've added that 4 in there. So we have to square the radius first, because remember with PEMDAS, exponents comes before multiplication. So you have to square the 3,963 and then multiply it with 4 pi. And I end up with an answer of 197,359,487 square miles. So that's the approximate surface area of the Earth. There will be times in class where you're just given the radius and you don't have to figure it out, but I figured I might as well make it a little bit more challenging since the formula is so easy. And of course, even if they don't give you the radius, there is normally a way to find out what that radius is, the way that we did here. All right, here's the next one. The sphere has a diameter of 60 inches. What's the volume to the nearest cubic inch? So I need to write down my formula for volume. It is 4/3 pi r cubed. I do need to figure out what radius is. I know that diameter is 60, so that means that my radius must be 30 inches. I take that 30 and I just plug it in right where I see the r for radius. And when I actually figure out what that is, that ends up being 900 square inches, or cubed inches. And then once I actually work that out, that's 1,200 pi cubic inches. Now they had asked me to leave my answer in terms of pi, that would be it. But in this case, it actually said to the nearest cubic inch. So that means that I have to put it all in my calculator, and that's approximately 3,770 cubic inches. All right, I told you that this video was going to be a quick one. That's all you need to know about spheres, surface area and volume.